This is actually section 10.5 of our book. It's the Pythagorean theorem. And a theorem in math is simply the truth, a certain truth in math. And this truth is with regards to 90-degree triangles. What are 90-degree triangles? Right triangles. Like this is a 90-degree triangle where you have a perfect corner, right? And the truth about this triangle is when it's a 90-degree triangle, a squared plus b squared will equal c squared. So a would be the shorter side. B is the other shorter side. A and B are both known as legs. And the c value is known as the hypotenuse. The hypotenuse is always the longest side of a 90-degree triangle. And it is always going to be the side opposite of your biggest angle. In this case, the side opposite of the right triangle, of the right angle, I'm sorry. So here's your right angle. This is a smaller angle. This is a smaller angle. Here's your 90-degree angle. Opposite of it is the longest side, and that's called the hypotenuse, okay? So if you take one of your shorter sides, which is called the leg, and you square it, and then you add it to the other leg squared, the other side squared, you're going to get a number, and that number should be equal to that hypotenuse, the longest side squared. So let's take a look at how the book looks at it. So here's what the book explains, the Pythagorean theorem. What is it? In a right triangle, the side opposite the right angle is called the hypotenuse, right? So here's the right angle, opposite of it. That c value is called the hypotenuse. And it's always the longest side, right? The other two sides are called legs. The A and the B, those are legs. And the Pythagorean theorem itself, they write it as c squared equals a squared plus b squared. But I like to write it a squared plus b squared equals c squared, right? Anyway, in order to really be able to use this theorem, this truth about right triangles, you got to know and identify which one is your hypotenuse, right? So it's always opposite the right angle. So right here, the hypotenuse, is this the hypotenuse? No. Is this one? No. It's this one? Yes, right? This is the hypotenuse. Why? Because it's the side opposite your 90-degree angle, okay? So this is your c value right there. How about this guy right here? Which one's the hypotenuse? This one, or this one? It's obviously this one. It's the side opposite your 90-degree angle. That's your c value right there. And this long, skinny, ugly triangle, the hypotenuse would be opposite your 90 degree, which would be this one right here. So I just want to show you some examples of which ones are your hypotenuse, the c value, the longest side, which is always opposite of the biggest angle, which in this case is a 90-degree angle on a right triangle. So once you memorize the formula a squared plus b squared equals c squared, you're going to be able to use that, it's not a formula, it's a theorem, but you're going to be able to use that theorem to find missing sides of 90-degree triangles. So right here you have the side 10, the other side 24. Those are legs, 10, 24. And it's missing the hypotenuse. So you want to find that missing value. How much does it measure from here to here? Well, you're going to have to go a squared plus b squared equals c squared. They say c squared equals a squared plus b squared. So your a value, they call it 10, so they put 10 squared. The b value, they call it 24, so they put 24 squared. So c squared equals 10 squared plus 24 squared. And you're going to be using your calculator a lot to do this. 10 squared is 100. 24 squared with the calculator is 576. Add these two with the calculator, you get 676. Now, how do you get rid of a square? You have to use a square root to get rid of a square. So to get rid of the c squared, you're going to have to square root it. You're going to have to square root it. Now, whenever you apply a square root in an equation, you have to put a plus or minus in front of your answer. So when you do the square root of 676 with your calculator, you will get 26. So the answer C is equal to either positive 26 or negative 26. The plus or minus is there when you're solving an equation. But because this equation is based off of this actual figure, this triangle, and actual measurements, there is no such thing as negative units when you're talking about measurements, right? From here to here, it's 26 inches. It's not negative 26 inches, or it's not negative 26 feet. Measurements, the distance is always positive, so you're not going to put a plus or minus. It's just 26, okay? The length cannot be negative, so the missing length is just 26 units. So with this a squared plus b squared equals c squared, or the way they write it, c squared equals a squared plus b squared, you could identify your a, your b, and your c. Your c is always opposite the 90-degree angle, and you could plug in those values and then solve the equation, right? You plug in 7 for a, there's a, plug in 7. B you don't know, so leave it as b. 15 is the c value, right there. 15 squared with the calculator is 225. 7 squared with the calculator is 49. You're going to subtract 49 with the calculator. 225 take away 49 is 176. You want to get rid of the square, you're going to do a square root. You're going to have b equals, it is going to be a plus or minus if it were a regular equation without an actual measurement, right? But because it's a measurement, you don't have to worry about the plus or minus. It's just going to be positive. And if you did the square root of 176 on a calculator, it'll give you 13.27. Actually, it doesn't give you 13.27. This is an approximation because when you do it on the calculator, the square root of 176 is a crazy irrational decimal, and it continues forever. So obviously, bless you, they rounded it to the nearest hundredths, right? So if you look at this next number 6, that changes that 6 to a 7. So 13.27 is the approximation of this missing side. However, that's what the book does, but in our worksheet, I am going to ask you guys to leave it as a radical. So instead of writing it as 13.27, I'm going to ask you to leave it as a radical in simplified form. So if you hit this SD button, it switches it from your fraction to a decimal, or from your square root, your radical value to a decimal, or decimal to square root. So the square root of 176, it simplifies down to 4 square root of 11, which is the exact same thing as 13.27, the approximation. So I'm going to ask you on your assignment to write it as a simplified fraction. So just, simplified radical, simplified square root. So you would just type in square root of 176, and that would be your answer right there, 4 square root of 11. So this is the type of question you're going to have on your assignment. And let me just move this to the side real quick. So we have a triangle. It says state the missing side. If you have an irrational answer, if you have a crazy decimal, then please type it in simplified radical form. So we need to remember the Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. Of course, you could put c squared equals a squared plus b squared. It's up to you how you prefer that. So let's label the a value. What is a? 3. What is b? 4. And it doesn't really matter if you call a 3 and b 4, or a 4 and b 3. As long as you know that your longest side is opposite the 90-degree angle, which is a c value, right? So you're going to have a squared, that's 3 squared, plus b squared, 4 squared, equals c squared. So when you do this math, you're going to end up with 9 plus 16 equals c squared. 9 plus 16 is 25. 25 equals c squared. I want to write it as c squared equals 25. I always like having my letters on the left and the numbers on the right. And to get rid of a square, you have to square root. And what you do to one side, you do to the other side. So your answer is c equals plus or minus 5. Why plus or minus? Because whenever you're solving an equation and you apply a square root in an equation, you have to put a plus or minus in front of your answer. However, because we're talking about an actual triangle and we're talking about an actual measurement from here to here, we know that there's no such thing as negative measurements, so we just say c equals 5. So that c value is just 5, and that's your answer. And that's how we're going to be using the Pythagorean theorem. Here's another one. Again, we're going to find the missing side. Let's begin by writing down the Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. So they tell us that, well, they give us the b, so they don't give us the b, which means b stays b. So I have a b squared. We know that the c value is the side, the longest side, which is opposite the 90-degree angle, which is 21. So you have 21 squared, and the a obviously is the 4 squared. A squared plus b squared equals c squared. All right, so we could do this math easy. 4 squared is 4 times 4, that's 16. 16 plus b squared equals 21 squared. I don't know what 21 squared is. I want to do it on a calculator. 21 to the second power. Actually, here's a screenshot of that. 21 to the second power is 441. Again, there's a power of 2 button, right? Just type in 21. That button, hit equal, it'll give you 441. And then solving it, you would subtract 16. And subtract 16. And using the calculator is a little bit safer. So you have b squared equals, with the calculator, 425. Now, we need a square root to get rid of that square. And what you do to one side, you do to the other side. So you have b equals plus or minus, but we know that we're not going to have the minus because it's an actual measurement of a distance. So the square root of 425 is 5 square root of 17. Okay. So that's the missing side right here. That's 5 square root of 17. If they said for a decimal approximation, you would hit the SD button on the calculator and it'll give you that crazy decimal, 20.615522813, and it goes on forever. But you would round it probably to the hundredths place, which means you look at the third one out, and that changes the previous one up to a 2. So it's roughly 20.62. But I want you to type it in as 5 square root of 17 as opposed to 20.62. So here's a interesting one. So what is our A value? What's our B value? What's our C value? Do we know A? What is A? A is 9. Okay, do we know B? B is 2 square root of 10. And do we know C? We don't. We know it's that longest side, the side opposite the 90-degree angle. So we're going to begin by writing down the Pythagorean theorem. A squared plus B squared equals C squared. Now, a lot of students are going to freak out because of this guy right here. But in reality, it's actually easier. You see, when you plug in your values that you know into the theorem, A squared, that's 9 squared, that's pretty easy, plus B squared. Now, I recommend doing this, plugging in the 2 square root of 10 right in there, and then you have the equals C squared, which you don't know, okay? So 9 squared, that's easy, that's 81. And plus, what is 2 square root of 10 squared? It's a little complicated, but let me show you on a calculator. Be very careful when you type this in. You see, I type in the open parenthesis, and I type in 2 square root of 10, and I try to close parenthesis, but look at this problem. When I close it, it closes it inside the radical, and you don't want it inside the radical. So what you're going to have to do is hit this button before hitting that, all right? So you're going to type in open parenthesis, 2, square root button, 10, and then you're going to hit this button to get out of the radical because it's still inside the square root. You're going to hit the side button to get out of the radical, then you could hit that. So again, I had to hit the side arrow to get outside of the radical, then I could close the parenthesis, then I could hit the power of 2, and then it gives me the nice answer 40, okay? So we have a 40 right here, equals C squared. And then you could actually add 81 and 40, that's going to be 121 equals C squared. I like seeing it as C squared equals 121. And to get rid of the square, you square root and you square root, which means C equals plus or minus, but we know that we're talking about distance, which is always positive, which would be 11. So this distance from here to here is 11, okay? So I think we've done enough examples that we could move on to the second half of this lesson. The second half is just using the converse of the Pythagorean theorem. It's just simple. We could use a Pythagorean theorem to find missing sides, or we could check the sides, all 3 sides, to verify that it's a 90-degree triangle, okay? Let's read what it says right here on the key concept of the textbook. If a triangle has the lengths A, B, and C, such that the Pythagorean theorem, C squared equals A squared plus B squared, then the triangle is a right triangle. if a squared plus b squared does not equal c squared, then it's not a right triangle, okay? For example, let's say you see that there's a triangle, something like this, I don't know, and you don't know if this is a 90-degree angle. This doesn't look like a 90 degree, this doesn't look like a 90 degree. 90 degree is a perfect corner, right? The question is this guy right here a 90-degree triangle? So we don't know if it is or if it's not. We could use and we could use the sides, like let's say there was a 3 here, a 4 there, and a 5 there, okay? You could use those sides to verify whether this is or isn't a perfect 90-degree angle, if it's a 90-degree triangle. So how do you use the sides? By using the Pythagorean theorem. So if you use the Pythagorean theorem, does 3 squared plus 4 squared equal the longest side squared? And yes, it does. 3 squared is 9, 4 squared is 16, 5 squared is 25, 9 plus 16 is 25, and yeah, 25 equals 25. So we've double checked it, we verified. You would say, yes, this is a right triangle, okay? So you could use the Pythagorean theorem. If you see all the 3 sides, you could use those 3 sides to verify that the Pythagorean theorem works. And if it does work, that means that you could conclude that for sure this is a 90-degree angle right there. It's a 90-degree triangle. Does that make sense? As a matter of fact, I have a uncle that owns a construction company, and one time he was working at my house. He was laying out cement. We were working, and he wanted to check, or I wanted to check and verify if we made the forms for the concrete perfect, like as in a perfect corner, right? So I was like, is this actually 90 degrees? It seems kind of off. So there's a tool to check it, but my uncle says, nah, you don't need the tool. Just check the 3, 4, 5. And I'm like, what do you mean 3, 4, 5? And this is real, guys. He says, if you measure from the corner 3 feet this way, and if you measure from that same corner 4 feet this way, and then you measure from this point to that point, that should be 5. And if it's not 5, then it's not a 90-degree angle. Later, I realized, he was talking about the Pythagorean theorem, right? So 3, 4, 5 is a way to verify that that's a perfect 90-degree angle, any corner, right? So might as well talk about these nice numbers, 3, 4, and 5. This is what we call a Pythagorean triple. What is a Pythagorean triple? According to the book, it's a group of 3 counting numbers. What do I mean by counting? Numbers that are not crazy, irrational decimals, that satisfy the equation, the Pythagorean theorem, where C is the greatest number. Examples, 3, 4, 5, right? 3, 4, 5, these are what we call a Pythagorean triple. And you could actually take the 3, 4, and 5 and multiply them by whatever you want, and it would still be a Pythagorean triple. In other words, 6, 8, 10 is also a Pythagorean triple, or 15, 20, maybe let me use a different color here. 15, 20, 25, that's also a Pythagorean triple. All I did was take the 3, 4, 5 and multiply it by 2 to get the blue 6, 8, 10. And I took the 3, 4, 5, and multiplied those red ones by 5 to get 15, 20, 25. Those are all Pythagorean triples, right? Anyway, what kind of questions are you going to have with regards to Pythagorean triple? Here it is. It says, if a triangle has the sides 9, 15, and 12, is it a right triangle? Well, what do you guys think? Is a triangle that has the sides 9, 15, and 12 a right triangle? You're going to verify that by doing the Pythagorean theorem, a squared plus b squared equals c squared. So if this is true, then it is a right triangle. So let's begin with that. What do I plug in for a, b, and c? What is my a value? 9, okay, 9 squared. What's my b value? 12, that's right. So 12 squared equals, what's my c value? 15. C value is always the longest side. So if I did, we're going to do 9 squared, I get 81. 12 squared, that's 144. And 15 squared on a calculator, 15 to the second, to be safe, is 225. So when we add 81 plus 144, on a calculator, it really does give us the same value, 225. So 225 equals 225. I've double checked it. I've verified. What have I verified? That yes, this is a right triangle. Okay, this is a right triangle. Okay, so it asks us, if it has these sides, is it a right triangle? The answer is yes. Are these sides a Pythagorean triple? Well, if you have counting numbers, as in regular numbers, right, like 9, 15, and 12, then yes, they're a Pythagorean triple, right? So which multiple choice option is the correct one? This one right here. Yes, this is a right triangle, and these numbers are a Pythagorean triple. Okay, let's look at our other options. Yes, it's a right triangle, but these numbers are not a Pythagorean triple. No, that's not the case. When would that happen? When this does check out, but one of these sides was an actual square root. It's not a counting number. It's an irrational number, right? This one doesn't even make sense. No, it's not a right triangle, but the numbers are a Pythagorean triple. If it were a Pythagorean triple, it would be a right triangle. So this doesn't even make sense. The last option, no, this is not a right triangle, and the numbers are not a Pythagorean triple. That might happen as well. Let's look at another similar one like this. Here we go. We have 5, 7, and the square root of 74. If you're wondering which is the longest side, it might be 7, it might be the square root of 74. You could do the square root of 74 on a calculator, change it to a decimal, and that's 8.6. So obviously 8.6 is the largest side, which is the square root of 74. So you're going to set this up. A squared, which would be 5 squared, plus B squared, which is 7 squared, equals C squared, which is the square root of 74 squared. So when you do this math, you're probably thinking, oh, this is ugly, square root of 74 squared. It's actually even easier. Why? Because the opposite of a square is a square root. The opposite of a square root is a square. It undoes itself. It's kind of like if I said, what's 74 plus 1,000, take away 1,000? It's still 74, right? What's the square root of 74, but then square it? It's still 74. The square root and the square, they undo themselves. They're inverse operations. So what I really have here is 25 plus 49. That's 25 because 5 times 5 is 25. 7 times 7 is 49. Equals the square and the square root undo themselves, so that's just 74. So if I add 25 plus 49, will it give me 74? And the answer is yes. So 74 does equal 74. So this is, yes, it's a right triangle. Okay, it's a right triangle. And is this a Pythagorean triple? Absolutely not. Why not? Because one of the sides was an actual square root, which is a crazy irrational decimal. So no, not a Pythagorean triple. Not Pythagorean triple. Okay, so that would be this answer right here. Yes, it's a right triangle, but these numbers are not a Pythagorean triple. And if you try this one right here, 15, 30, and 34, are these sides a Pythagorean triple? So let's try to do that. 15 squared plus 30 squared equals 34 squared. 15 squared plus 30 squared on a calculator is 1,125. And 34 squared on a calculator is 1,156. So obviously these are not equal to each other. So this is not a right triangle. It is a different type of triangle, but definitely not a 90-degree triangle. So no, it's not a right triangle, okay? Which means that for sure this is not a Pythagorean triple, which is this option right here. All right, guys, I hope this helps, and this is already posted on Google Classroom, and also there's an assignment with these similar or exact questions.